11-1 is simplifying rational expressions. All right. Now, a rational expression is an expression in the form of a polynomial divided by a polynomial. For example, if we had x plus 3 over x plus 6, that is a rational expression. Okay? To simplify, when we need to simplify rational expressions, to do that, to simplify a rational expression, we will divide out common factors from the numerator and the denominator. Okay? Now, because the rational expression is a fraction, okay, there are times when we have excluded values. Okay? What value cannot be in the fraction, in the denominator of a fraction? All right. So 0 cannot be in the denominator of a fraction. So when we are simplifying rational expressions, we have to take into consideration that fact. We cannot have 0 as the denominator. Okay? All right, so problem 1 is simplifying a rational expression. Okay? Simplifying a rational expression, same thing as simplifying a fraction. Okay? So we want to know what is the simplified form of the expression, and we want to state any of the excluded values. We want to know what can x, or whatever the variable is, what can it not be equal to. Okay? So first thing I want to do is I want to figure out what can I factor out of both the numerator and the denominator. 7a squared, right? So we're going to divide out the common denominator, or the greatest common factor. So we're going to divide by 7a squared in the numerator, and we're going to divide by 7a squared in the denominator. So when we do this division, we're going to end up with, let's see, 21a squared divided by 7a squared is going to give me 3. And the denominator, 7a squared cubed divided by 7a squared is just going to give me a. So there's my answer, 3 over a. What can a not be equal to? 0. So here, a cannot be equal to 0. That is my excluded value. Let's do letter B. Okay? For letter B, please note this we cannot simplify, or we can't factor. We can't simplify this yet, because of the plus, okay? You can only simplify like we did in the first fraction if everything is multiplication, okay? So, what can I factor out of this expression? All right, so we can factor out a 4, so we're going to rewrite the numerator. We've got 18d squared. And then, in the denominator, we're going to factor out the 4, and we'll be left with d plus 2, right? So now, because we have 18d squared divided by 4 times all of this in the binomial, now this is all multiplication, now I can simplify. So, 4 divided by 4 is 2. 18 divided by 2 is 9, right? So we're left with 9d squared all over 2 times d plus 2. Okay? So now we have to think about what can d not be equal to? What number will D be that will make this denominator into 0? Negative 2, right. So the excluded value, D, cannot be equal to negative 2. If you need to, you can show your work for your excluded values on the side, okay? All right. All right, so for letter D, can I factor anything out? So let's factor out a 13, okay? So when I factor out a 13, we've got, when I factor out a 13, we're going to end up with 2C. Oh, I can factor out 13C, right? Right? Let's redo that. So we're going to factor out a 13C. We'll be left with 2C squared. And then over here, plus 7, right? All over 2C squared plus 7. Now, you have a binomial on top and the same binomial on the bottom. What can you do? Cancel them out. And when you cancel them out, what's left in their place? Ones. Very good. We've got ones left in their place. So, our final answer for this will be 13C times 1, which is 13C, over 1, which is just 13C. Is there any value of C, or is there any value that C cannot be? Because this is not a fraction, we don't have that divide by 0 error, right? So that means that here there are no excluded values. Okay? Problem 2 is simplifying a rational expression containing a trinomial. So for the first example, we have 2x minus 8 divided by x squared minus 2x minus 8. Okay? So, in the numerator, can I factor something out of there? I can factor out a 2, right? So, we'll have factor out the 2, and we're left with x minus 4. Okay? In the denominator, we have a trinomial. Do I know how to factor a trinomial? Yes. On this one, I'm going to go ahead and use the x method, right? Let's do it in our head. So, in order to get the x squared, we have x times x. Okay? In order to get a negative 8, or an 8, we're going to multiply 1 times 8 or 2 times 4. But only one combination is going to give me a 2, right? So the combination will be 2 and 4. Now when we add, now remember, one has to be positive, one has to be negative. When we add, we want the answer to be a negative 2. So that means that the bigger number has to be the negative. So negative here, positive there. Now my trinomial is factored, and now I can start simplifying. So here I've got an x minus 4 and an x minus 4. Those both simplify to 1. And what's left is 2 over x plus 2. 2 over x plus 2. What is my excluded value? Well, I'm going to write it. X cannot be equal to what? Negative 2. Very good. All right, for letter B, we can factor the numerator, and we can factor the denominator again. So, let's see. Again, we can use the x method for the numerator. So, a squared is a times a. To get 2, there's only one choice, right? 2 times 1. We want them both to be negative because when we add 2a plus 1a, we want it to be a negative 3a, right? So they both have to be negative, and a negative times a negative is a positive for positive 2. That divided by, what can I factor out of the denominator? 3. So we're going to factor out of 3, and we're going to end up with a minus 1. And now, we can factor out our a minus 1s. So what we're left with is a minus 2 over 3. Now looking at that problem, is there any value of a that I have to throw out? No, because there's no variable in the denominator of this fraction. Does everybody see that? So there are no excluded values. No excluded values. First, for letter C, we know that we can factor out a 6 out of the numerator. So this is going to be 6 times the quantity z plus 2. Now, the denominator, we're going to use the AC method because we have a 2 and a 6. We have the 2 in front of the first term, so we're going to use the AC method there to factor. So, there's the AC method that I did over on the side. So now our factors are going to be the 2z plus 3 times the z plus 2. And now you can see that you can factor out the common binomials. So here, the z plus 2 cancels both 2 1s in the numerator and the denominator. And we're left with 6 over 2z plus 3. Now, what will our excluded values be? Z cannot be equal to, remember, to find your excluded values, you're going to set the denominator equal to 0. So when you do that, you have 2z plus 3 equals 0. We're going to subtract 3 on both sides. So 2z is equal to negative 3. We'll divide by 2. So z is equal to negative 3/2. So our excluded value is negative 3/2. We have, in this problem, we have the numerator and the denominator of x minus 3 divided by x, 3 minus x are opposites. These are not the same binomial. Okay, they are not the same. Because remember, the operation is also the sign of the number that follows. So, if I were to rewrite this, x minus 3, if I flip the denominator around, okay, this would be a negative x, and this is a positive 3, right? So that would be plus 3. So they are not the same. They are opposites. And the way that I know they are opposites is that if I factor out a negative 1 in the denominator, then they become the same. You see? So, I've got x minus 3 in the numerator. If I factor out a negative 1 in the denominator, I'm going to get a positive x and a negative 3. Now we have the same. The reason they are opposites is because they only differ by that negative 1. If you multiply or divide by a negative 1, then you know you have opposites. Is everybody clear? Okay? So now, here, you can cancel these out to 1s, and you will just end up with 1 over negative 1, which is equal to negative 1. Okay? So they only differ by that negative 1. All right. So recognizing opposites. I'm going to do letter B because letter A is just like the problem we just did. It's exactly the same. But letter B, here we have y squared minus 16 divided by 4 minus y. Okay? So we want to do some factoring first to see if we can cancel stuff out, right? So here, this is a difference of squares. Remember, a difference of squares is the sum of the binomial and the difference, right? So we're going to have over here, we're going to have a sum and a difference. So we've got y times y, 4 times 4. One's going to be plus, and one's going to be minus. All right. So here you can see we almost have something that we can cancel out, right? But we can't right now. I can go ahead and flip that around, right? So if I flip that around, the denominator, if I flip the denominator around, I'm going to get y plus 4 times y minus 4 over negative y plus 4. Now here, I can go ahead and factor out a negative 1, right? So when I factor out the negative 1, let me rewrite the original, y plus 4 times y minus 4. We're going to factor out a negative 1 here. So that's going to be a positive y and then a negative 4. So minus 4. So now I have something I can cancel. Does everybody see that? So we can cancel those to 1s. And we're left with y plus 4 over negative 1. Can I put this negative here, here, or here? Just like a fraction. It can go anywhere. In the top, right in the middle, or in the bottom. Okay? So what I'm going to do is I'm going to go ahead and write this negative up there. Okay? So this is going to be a negative y plus 4 over 1. So does everybody see that's going to be the same thing? So now, what can I do with this? You can distribute. So our final answer then is a negative y minus 4. All right, problem 4 is using rational expressions. A square has a side length of 6x plus 2. In a rectangle with a width of 3x plus 1, they have the same area. The square and the rectangle have the same area. And we want to know what is the length of the rectangle. So we know that the area of the square is equal to the area of the rectangle. And we also know that area of a square is side squared, and the area of a rectangle is length times width. So now we just solve for the area. So for the area of the square, side squared, we've got 6x plus 2 times 6x plus 2, and that's equal to the length times the width, which is 3x plus 1. So now, all we have to do is solve for the length. So we're going to divide by 3x plus 1 over there, and we'll divide by 3x plus 1 on this side. So now you can see that the 3x plus 1's will cancel, and we're left with the length on that side. And then over here, we got to do some factoring. So we can take out a 2 in both of those. We can factor out a 2 in both of the binomials in the numerator. So we've got 2 times 3x plus 1. And we've got another 2 times another 3x plus 1. And that's going to be all divided by 3x plus 1. So now we can cancel. Now you can only cancel 1 to 1. So you can only cancel once. You cannot cancel this one with the 3x plus 1 in the denominator. So this is what we're left with. Okay? So the length then is equal to 2 times 2, which is 4, times 3x plus 1 units. I can simplify a little further by using our distributive property right here. And we end up with the length will be equal to 12x plus 4 units.